In this tutorial, we're going to talk about Boolean values and conditional operators in Grasshopper. Boolean variables can only store two opposing values. Under params primitive, you can find Boolean container. It's an input parameter for storing Boolean value. To define Boolean value, we can go under params input and choose Boolean Toggle. We have used this parameter object many times before, but just to remind you, we can switch between these two values by double-clicking on the toggle. And in fact, you can see we have either true or false. So again, Boolean variable can only be one of two opposing values. It could be yes or no, true or false, 1 or 0. Now let's try using a number slider. Let's double click on canvas and define the bounds from 0 to 1. And also let's use this Boolean container to make data conversion here. I'm going to grab a panel. And here we can read that 0 is converted to false and 1 will be converted to true. And I talk more in depth about these conversions in another tutorial. I'm going to link it in the description below. So Boolean values are used to evaluate conditions or statements that starts with if or what if. As you can imagine, there are many ways to construct conditions, but in this tutorial we're going to focus on conditional operators. And this way it's the simplest one. Under math operators, you will find 4 conditional operators that we are going to discuss in this tutorial. So it's equality, similarity, larger than, and smaller than. For this tutorial, I'm using an array of points along y-axis created with the range and construct point components. But for now, we're only going to focus on the output values of a range component. So let's go under Math Operators to pick Conditional Operator. Let's begin with larger than. Conditional operators evaluate numerical values. So if we hover over the input parameters, you can see that it's numerical values required. So let's input range output values as A input in the larger than component. And for B input, we're going to use number slider. So let's double click on canvas and type in something from -1 to 10. And then connect the number slider to the B input. Let's go under params input and grab a panel to analyze the output from larger than component. What we get is a list of Boolean values. And our conditional statement in this case is if A is larger than B, then print true. In this instance, because the B input is number -1, all the output values are true. Of course, we can manipulate the number slider and change B input value. And pay attention to the larger than output. You can see that now we have some false values in the list. And if we choose input number 10, then all the output values are false. If we look at the second output, which is larger than or equal to, the last value in the output list, in this case, is going to be true. The concept of such conditional operators is easy to understand. It's a simple math, but just in case, let's go through all of them. So let's go again under Math Operators, and this time let's pick smaller than component. The smaller than operator is the opposite to larger than, which means that given the input parameters are the same, smaller than operator would output the opposite values. So if larger than outputs true value, then smaller than would output false value. And of course, vice versa. Let's pick another operator. Let's go again under Math Operators, and this time let's choose equality. Equality operator tests whether A input values are equal to B input value. In my case, B input value is number 5. So there is only one value in A input list that is equal to number 5. It's item with index 5. And in the output panel, you can see now it says true. If we check the second output, which is the opposite of equality or not equal, then you can see that the Boolean value switched to false. Time to talk about the last operator. So again, let's go under Math Operators, and this time let's pick Similarity. And let's reconnect. So range output values, let's input into A, and the second number slider into B. To better understand how the Similarity component works, I suggest we change our setup. I'm going to go to the range component and change the number of steps. Double click on panel and type in something like, let's say 13. Click OK. And this way we get a list of floating values or floating numbers. At this point, the similarity operator performs as equality. And this is because the threshold value is low, so the precision is high. Therefore, all the output values are false because none of the input A list items matches number 5 within given threshold. Threshold parameter is set to be 0.1 and it's in percentage. So the values could be from 0 to 100%. So let's double click on canvas and use number slider. I'm going to type in 20, plug in. As soon as we plug in new threshold value, notice how some of the output values flipped. Specifically items with indices 6, 7, and 8. I'm going to make a copy of the panel and let's see why these specific items flipped. So let's connect the second output, dt, absolute difference, to the second panel. I'm going to name the panel for clarity. So let's analyze what's happening here with a specific example. Let's look at A input list and let's take item number 6 with a value of 4.615 and so on. 20% of this specific value is something about 0.92. And this value is larger than the absolute difference value assigned to this item. Therefore, item with index 6 is taken as similar to B input value, and thus the similarity component returns true. Let's now have a look at item with index 8 with a value of 6.15 and so on. 20% of this value is somewhere around 1.23, which is again larger than the absolute difference value assigned to this item. But if we check the second number, obviously 20% of 5 is lower than 20% of 6, but it's also lower than the assigned absolute difference value for item 8. So if only one calculated threshold value of either A or B input is larger than the absolute difference value, the A and B input values are taken as similar ones, and thus the operator returns true. We are going to continue talking about conditional statements using logical operators in the next tutorial. But for now, before I go, I'd like to reiterate that there are many ways how we can construct conditional statements in Grasshopper. For instance, you can go under Curve, Analysis, and check out Pointing Curve and Pointing Curves components. There is a nice example file in Grasshopper which I encourage you to investigate and try to understand how this definition works. You will find this file in the main menu bar under Help, Tutorial Files, choosing Adaptive Pattern within Shape. So definitely do that, and I will see you in the next tutorial.